Good morning students, I am Dr.R.Suganya, Computer Science with Cyber Security. Today we are going to see about public key cryptography. So before going into public key cryptography, we have to know about what is cryptology, symmetric ciphers, asymmetric ciphers, Diffie-Hellman and RSA. So we know that cryptology means public key cryptography. It is a method of encrypting or signing data with two different keys and making one of the keys the public key available for anyone to use. The other key is known as private key. Data encrypted with the public key can only be decrypted with the private key. The signs of keeping data secure. Example, public keys of every user are present in the public key register. If B wants to send a confidential message to C, then B encrypts the message using C public key. When C receives a message from B, then C can decrypt it using its own private key. The main business applications for public key cryptography are digital signatures. Content is digitally signed with an individual's private key and it is verified by the individual's public key. Encryption. Content is encrypted using an individual's public key and can only be decrypted with the individual's private key. Two transformation algorithms, enciphering and deciphering, symmetric ciphers, asymmetric ciphers. Symmetric ciphers, it is also known as private key. Both parties must agree on the key in advance. So that is a formula. So not very computationally intensive. Key must be securely sent to both parties. Symmetric cipher example. K equal to 4. Turn the plain text secret into ciphertext. So we can know that enciphering and deciphering. So from plain text to ciphertext and ciphertext to plain text, it is deciphering. So here we can have ciphers example. Symmetric cipher example, we can say elaborating the transformation. So it is complicated that even if the transformation was public, a key would still be needed. So still require a distributed key. Asymmetric cipher, it is also known as public key. Two keys are needed, public key and private key. So private key is not required for both the parties. So more computationally intensified. So in this diagram we can see that how the public key is being used. Next is about Diffie-Hellman, which uses a public key. So one of the first public key cryptographic system. So Diffie-Hellman is one of the first public key cryptographic system. So it is developed by Martin Hellman, Ralph Merkley and Whitefield Diffie at Stanford University in 1976. Diffie-Hellman, based on a special case of subset sum or knapsack problem. Diffie-Hellman example, here it is called as block cipher. So the block size of 7 bits and it is possible 2 power 7 combination. So private key can be set from A1, A2 to AN of 7 integers what's given here, and we can choose two special integers with the variable name W and M such that it is relatively prime, meaning it has some value to it. So public key is 7 integers. So partition the secret into 7-bit blocks, each block which consists of xn bits. So here we can see in the word of secret. So how it is mean? The integer is being transformed, okay, from the private key. So here we have formula sum of the whole power n x of I into ai. So here the formula is used and it is applied and we have got the block ciphers. So here two possible points of vulnerability. An algorithm which solves NP complete problems quickly. An algorithm that solves the particular problem on which a cryptographic system is need. RSA. So RSA is also one of the public key algorithm. So it is developed by Ron Renvest, Adi Shamir and Leonard Adelman at MIT in 1977. So it is based on the difficulty of factoring large numbers. Factorization is so far as unsolvable in polynomial time. So here we can have RSA example. Find two large prime integers, that is P and Q in the product form, and it is relatively prime number. So message is partitioned into blocks. So each block is encrypted using the equation C equal to DE mod n. So for the private key, calculate the integer which is modular inverse. So once D is calculated, it becomes your private key and all records of P and key should be destroyed. So each encrypted block, that is C, is decrypted using the equation. So here we have got the encryption and decryption values. So RSA here, the security of RSA actually relies on two assumptions. Factoring is required to break the system. The another was factorization cannot be done in polynomial time. So these are the two things. So summary about, so we have seen about cryptography, that is cryptology, that is using the public key, and using the public key symmetric and asymmetric ciphers, and Diffie-Hellman and RSA. Thank you.